Okay, in this video, we're going to try to do what's called a general graph of a function you may not be very familiar with. Now, I want you to understand we're not going to be looking for exact locations. What we're going to be focusing on is the x-axis. And when you look at this graph down here, I didn't even label the y-axis because we're not going to be too worried at the moment about how high or low this function goes. I want to see what its general shape might be. What are some general characteristics? Now we can get these from a lot of the techniques you guys already know. If I have a function and I don't really know anything about it, the first thing I would like to know is, does it touch the x-axis, does it cross the x-axis, and where might that happen? Okay, so to find that, I'm going to factor this, and I'm going to set it equal to 0. That would tell me its zeros, or its roots, or its intercepts, or its solutions. There's a lot of words used for that, but it's basically telling me where it touches that x-axis. So I'm going to take this, and I'm going to factor out a greatest common factor first, because that's a technique I can see right now would be helpful. So I'm going to write x, and then I've got some stuff left over, equals 0. So inside here is going to be x squared plus 1x minus 20. And now I see a trinomial there, so I think I'm going to do this. This is something that should look familiar. X and x, we'll backwards FOIL this and get 5 and 4, positive and negative. And hopefully your habits by now will pretty much tell you that you need to make each one of these things equal 0. So my solutions would be x equals 0, negative 5, and positive 4. Now, these numbers right here mean something on a graph. Those are places where it touches or crosses the x-axis. So let's label those. I've got 0 right here, 1, 2, 3, 4, 5. So negative 5 and positive 4. Okay. So I know it's going to touch or cross at both places. Now there's some other things I know too. From our previous lesson, I want you to take a look just at the first term right here, and let's look at some features or end behaviors. What's happening at the very ends? Okay. So for example, this is an odd exponent, so that means my function is going in opposite directions. So it either looks like this or it looks like this. Okay, they're either moving with a positive slope or a negative slope. And now the way this one appears, this is a positive leading coefficient. It's positive 1 that's in front of that. So it means it's going to have a positive slope. It's going to be kind of like this situation right up there. This would be a negative slope. So I'm going to draw in some arrows that tell me it's going like this. Okay. Now all I have to do is connect the dots. I'm not going to worry about how high these little ups and downs might be. We'll get to that later. Let's just see what happens. Okay, I have to cross the x-axis here. Eventually it's going to have to turn around and cross the x-axis again, and then it's going to have to go right back up and cross it again. And there's the general shape of that function. Okay, these maxes and mins right here and right here, those high and low points, we'll get into how to figure those out at a later time. Right now we're just worried about a general shape. Okay, so there was 3 roots, just to reiterate, 3 roots or 3 zeros, and I got those up here from doing my factoring. Okay, so a lot of our techniques and skills are starting to sort of come together and collide, and they'll be useful in bigger situations. The hard part is there isn't a set of instructions that just says, step 1 do this, step 2 do that, step 3 do that. It's not that way. We've got to look at something that we're given and be creative enough to go, okay, what can I do to write this a different way that might reveal some characteristics about this function?